Welcome to our math lesson on cones. Today we're going to learn about the area and volume of cones, which are important three-dimensional shapes that appear in many real-world situations. Let's start by understanding what a cone is. A cone is a three-dimensional geometric shape that tapers smoothly from a flat circular base to a point called the apex or vertex. We'll label the important parts: the radius of the base, which we'll call r, the height of the cone, which we'll call h, and the slant height, which we'll call s. Before we calculate the area and volume, let's understand how the radius, height, and slant height are related. By the Pythagorean theorem, we know that the slant height s, the radius r, and the height h form a right triangle. So the slant height south equals the square root of r squared plus h squared. This will be useful when calculating the surface area. Now, let's calculate the surface area of a cone. The surface area consists of two parts: the circular base area and the lateral surface area, which is the curved part. For the circular base, the area is pi times radius squared. For the lateral surface, imagine unwrapping it. It forms a sector of a circle with radius equal to the slant height s. The total surface area is therefore the sum of these two parts, pi r squared for the base plus pi r s for the lateral surface. This simplifies to pi r times quantity r plus s. Now, let's find the volume of a cone. Interestingly, the volume of a cone is exactly 1/3 the volume of a cylinder with the same base and height. Since the volume of a cylinder is pi r squared h, the volume of a cone is 1/3 of that, or 1/3 pi r squared h. You can think of it this way: if you had 3 identical cones, you could fill a cylinder with the same base and height. Let's solve an example problem. Say we have a cone with a radius of 3 centimeters and a height of 4 centimeters. First, let's calculate the slant height. Using our formula, south equals the square root of r squared plus h squared. So south equals the square root of 3 squared plus 4 squared, which is the square root of 9 plus 16, which is the square root of 25, which is 5 centimeters. Now we can calculate the total surface area. Using the formula pi r times quantity r plus s, we get pi times 3 times quantity 3 plus 5, which is 3 pi times 8, or 24 pi square centimeters, which is approximately 75.4 square centimeters. And for the volume, we use 1/3 pi r squared h, which gives us 1/3 times pi times 3 squared times 4, which is 1/3 times pi times 9 times 4, which is 12 pi cubic centimeters, or approximately 37.7 cubic centimeters. Let's summarize what we've learned about cones. For a cone with radius r, height h, and slant height s, we've discovered that the slant height south equals the square root of r squared plus h squared. The total surface area equals pi r times quantity r plus s, which includes both the circular base and the curved lateral surface. And the volume equals 1/3 pi r squared h, which is 1/3 the volume of a cylinder with the same base and height. Cones appear in many places in the real world, from ice cream cones to traffic cones to the shape of volcano mountains. Understanding their properties is important in many fields, including engineering, architecture, and physics. Thank you for watching. I hope you now have a better understanding of the area and volume of cones. If you enjoyed this video, please like and subscribe for more math lessons.